Right, 4-3, exploring congruent triangles. Hey, got a question for you. What quantity is represented by 3 congruent dirty trees?
Well, of course, it's 99, because dirty tree plus dirty tree plus dirty tree is 99. That's bad. That's a good one, though.
I like it. Yep. All right, definition of congruent triangles. Congruent triangles are 2 triangles that are congruent if and only if their corresponding parts are congruent. That means the parts that match up. So if I've got 2 triangles here, corresponding parts would be, the 2 sides that match up or the angles that match up. Okay? So in order for 2 triangles to actually be congruent, their corresponding parts have to be congruent. Congruent figures will have the same size and the same shape. So, definition of congruent triangles is this CPCTC. Corresponding parts of congruent triangles are going to be congruent. So corresponding parts, meaning the parts that match up, of congruent triangles, meaning the triangles have the same size and the same shape, have to be congruent as well. So that means if these 2 sides match up and these 2 triangles are congruent, if this is 5, then this is going to be 5 as well. All right, if we take a look here at some properties of our congruent polygons, all right, in this diagram here it shows that 2 triangles are congruent to each other. That means that their corresponding angles, like A and D, B and E, and C and F, also have to be congruent, and their corresponding sides have to be congruent. Now, how the heck did I know what matched up with what without actually looking at the matching colors and the lines? Well, this similarity statement tells you what matches up with what. A has to correspond with D, B has to correspond with E, and C has to correspond with F. Order matters. Okay? So likewise with the properties of polygons, let's say I've got polygon PQRS and polygon WXYZ, and I tell you that these are congruent, well that means that P and W have to correspond, Q and X, R and Y, and S and T. Likewise the sides, so if I take PQ, then WX would have to be congruent to it. Let's say I said RS. Well, YZ has to be congruent to it. The order matters. Look for the similarity statement. If they don't have a similarity statement, then look for the picture. The pictures are usually labeled to help you figure out what corresponds with what. So for example, if I've got triangle ACT here, and I tell you that it's congruent to triangle RMK, well then CTA, let's change the order, CTA would have to be congruent to what? Well, RKM. Let's switch it up again. Let's say KMR, so KMR. Well, then you go backwards again, triangle TCA. I would like for you to please pause me, and I want you to write down all corresponding sides and angles for the above triangles. All right, what you should have had is side CA being congruent to MR. Now, if you went backwards and said AC and RM, that's fine. AT and RK, and then CT and MK. Those for the sides. Now, for the angles, C would go with M, A would go with R, and T would go with K. If the 2 triangles here are congruent to each other, one's on top of the other, I would like to know XWY is congruent to what? Well, XWY, X matches up with what, you guys? Hopefully you said Z. W matches up with Y. And then we have W here matching up with Y again. Okay? Side ZW is congruent to what? Well, hopefully you said XY because X matches up with Z. Remember, you guys, I said order matters. So if you put YX, I'm going to mark it wrong. It's got to be XY, people. Order matters. I would like for you to do this last example. Tell me triangle ACB is congruent to what triangle? All right, hopefully you said EDB. E matches up with A, D matches up with C, and obviously B matches up with itself, B. All right, what if I give you an example that doesn't have a picture, it just has the similarity statement? Now, you could simply draw the picture if you'd like, but obviously it's going to take some time. What I would just do is follow the order of the similarity statement. So, angle P here has to match up with angle X. So these are going to be congruent. Z is congruent to B, and W would be congruent to F. I want you to go ahead and do the segments or do the side lengths and tell me which ones match up with which. Okay, PW would have to match up with XF, so these are going to be congruent to each other. XZ has to match up with PB, so PB and XZ are going to be congruent. And BW has to match up with ZF. So BW and ZF are going to be congruent. Remember, you don't need to draw a picture. If drawing a picture helps you, that's fine. But using the similarity statement is almost a little bit easier because you can see the direct order, what's congruent to what.
All right, so let's go ahead and take a look at this example. In this example, we are giving you two triangles, and we're saying they are congruent along with their side lengths for some portions of the triangles. The first part of this example, what we want to do is we're going to go ahead and draw and label figure showing the congruent triangles. So we're going to first draw out, let's go ahead and draw triangle GEO. And I'm doing my best job to draw out straight lines. So I got GEO. And it said that we're going to go ahead and have another triangle that looks exactly the same as that one did. And that triangle is going to be TAN. Now, the issue with this triangle is you've got to realize that if I started off labeling the first triangle with a G, then I have to label the second triangle with a T in the very same spot. The E then would correspond to the A, and the O would correspond to the N. Therefore, it is very important that you label them in this order. So wherever you started to label on the first triangle, you have to do the same exact thing on the second. Now, the next thing we're going to do is we're going to go ahead and take a look at the sides that they give to us. And they're telling us that GE is 22, so we'll label that. They tell us that EO is 25, and they're telling us that GO is 30. Let's do that. The next thing they do tell us is that TN is 4x minus 6. And that's the only thing they tell us on triangle TAN. Now, using this information, what we can do is we can go ahead and figure out what the value of x would be. Now, to figure out the value of x, I'm taking a look over on this triangle, and this is the only place in which I've got an x showing up, and it's for segment TN. Now, segment TN in the second triangle actually corresponds to segment GO in the first triangle. So we do know that these two triangles are indeed congruent, that 4x minus 6 has to equal 30. So that means that 4x would equal 36, and x would be 9. So what happens if I give you a diagram, and in this diagram I really have two triangles, and I'm asking you to tell me triangle KMP is congruent to what triangle? And order is really, really important in this case. You just can't slap down 3 letters. I'm looking for the specific order in which it'll occur. So if I start off in the first triangle with letter K, notice K has a single arc marking the congruency of the angle. And then it travels to M, and then it goes to P, which has a double. So really what I'm thinking is, on the other triangle, I need to start off with the single arc, go to what's shared, and then go to the double. So to tell me that triangle KMP is congruent to, I would say it's congruent to triangle KMT. I said K, didn't I? I meant Q. QMT. And order is important. If you switch it around, I'm going to mark it wrong. So the last example we're working with here gives me that we're working with two congruent triangles. So we've got triangle EFG and triangle LMN, and they are indeed congruent. And we're going to ask you a whole bunch of information here, and I want you to tell me what the lengths of the sides on these specific triangles are, along with the measurements of the angles. So first thing I'm going to do is, since I'm asking you about 6 of these, I might as well just go ahead and label everything in the diagram. So, let's go ahead and take a look. I want to know what this missing side is on this triangle, so EG. And if I look at EG, EG is actually the first and the third letter in this triangle that's listed, so it should actually correspond to triangle in the next triangle, L and N. So LN in the second triangle is actually 15, meaning EG should be 15 since the two triangles are congruent. That actually allows us to fill that in. The next thing we're going to take a look at is the sides of the triangle in the second one. So if I'm looking for NM, NM is third, second letters on the second triangle. So the third and the second letter on the first one was GF, so GF is 12. So NM should also be 12. ML, if we're looking at ML, ML, it's the second and the first letter. So the second and first letter on the first triangle is FE, and FE was a length of 7. It's actually working out pretty nicely. The next, angle M, we just might as well go in order of what we've got listed here. Angle M, well, M corresponds to F in the first triangle, and we do know that angle F is 97 degrees. So that means angle M should also be 97 degrees, because in congruent triangles, the sides are congruent and the angles are congruent. What about angle G? So if we take a look at angle G, I know angle G is in the first triangle, it's the third letter. So the third letter in the second triangle is N, and we know that the measurement for angle N was 31. So we know angle G is 31. The last thing we're working with is angle E. Now, you might be thinking, oh, well, angle E is the first letter, it corresponds to angle L, so all I have to do is look at the second triangle, angle L. Problem, there is no measurement here. So, let's back the train up. If you notice you're looking for angle E, do you have the other two angles in the triangle? Absolutely. And what do we know about angles in a triangle? They add up to 180 degrees. So if you take the 97 and the 31 and you add them up together, you're going to end up getting 128 degrees. That means I only need 52 more degrees, and that would be my angle E. So angle E is 52, and if I asked you the question about angle L, you could do the same exact thing with angle L. Alright guys, finish up your whisk, and we'll see you later.